The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Rachelle gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm Rachelle Saunders, guest hosting today for regular host Rachelle. Today, I'm very excited to be talking about something that's close to many people's hearts, and that, of course, is beer. And I'm pleased to be joined by Dr. Charlie Bamforth, professor of Malting and Brewing Sciences at UC Davis in California. In addition to having been involved in the brewing industry for over 34 years, Charlie is the editor-in-chief of the Journal of the American Society of Brewing Chemists and has himself published innumerable papers, articles, and books on beer and brewing, including Beer is Proof God Loves Us, Reaching for the Soul of Beer and Brewing, and Beer, Tap into the Art and Science of Brewing. So pour yourself a pint, unless you're driving, and get comfortable. Welcome to the show, Charlie.
Thank you for inviting me. It's nice to be here.
So what sort of a science background is handy to have if one wants to get into professional beer brewing? I mean, where did you start?
Well, I started as a biochemist, so I studied biochemistry at the University of Hull in England, and really my PhD was on enzymology, and the enzymology of what I was working on, which is bacteria, and the enzymology of barley and yeast, of course, is very similar. It's all about enzymes. So when they were looking for a person to work on the enzymes of brewing materials at the Brewing Research Foundation way back when, I thought, well, give me a job, I could do that, and it would be something that would combine my social interests and my professional interests. So that's how it all started.
So how long have humans actually been brewing beer for?
About 8,000 years, variously described as 6,000 to 8,000 years, but we can link it back to what we refer to as the Fertile Crescent, which is the region around Iraq, as we call it nowadays. And in those days, people had a nomadic lifestyle. They would drive goats in search of grass. And what the people ate was barley grain. Because they had barley that was growing wild in that region, and they would eat the grain, and they found it hard and tough and wasn't very pleasant to eat, and it wasn't desperately nutritious. But purely by happenstance, they found that when it got wet, it started to sprout and got softer and tasted like bean sprouts, so it was tastier and actually easier to digest and was better for them. And then they for some reason, started making it into a bread, and that tasted real good. And when they stored that bread in large jars and accidentally got it wet, interesting things happened. And when they drank the liquid, they sort of got a warm and happy feeling, all fell over. And they realized that something wonderful had happened, so that they stopped the nomadic existence and had a static lifestyle while they grew the grain and sprouted it and made this bread and did the jar thing. And those tents became cities and towns and cities. So I always say that, we can thank civilization, or the fact that we've got civilization is thanks to beer.
We actually had a question from a listener. Malcolm asks, I've heard the oldest written recipe in the world is reputed to be for beer. Would it still produce a good beer?
Well, I think he's referring to the Himton Ninkasi, which is something that stems back to the days of Sumeria. And that was clearly a recipe for the brewing of beer. And all I can say is that it was taken on board by a very legendary brewer in the United States called Fritz Maytag, a good friend of mine who was brewing in the Anchor Brewing Company in San Francisco. And he decided he was going to brew a beer according to that ancient recipe, and did so. And he consulted with archaeologists and people who could read Sumerian script, and they made it as authentic as they possibly could be. And they had a big drinking ritual when it was done, where they drank it in the old-fashioned way, and they had the beer in these pitchers, and then everybody drank it through a straw, because that's how it used to be done back in the day. And I said to Fritz, how did it taste? He said, Charlie, it wasn't desperately good, but we had tremendous amount of fun doing it. So the beer back in those days would be very dissimilar to what we have now, and probably not quite so pleasant, but nonetheless, I guess the alcohol would have made people quite happy even in those days.
So the beer would have gotten the job done in the end.
Absolutely, yeah, always does.
So how much has the recipe and the process for making beer actually changed over the last few thousand years?
Well, considerably. But nonetheless, if you go back, say, 400, 500 years, and you turned up in what then was a brewery, you'd recognize it. You'd know that it was a brewery because the basic shape of the process hasn't changed. So, I mean, for the longest time, people have been making beer, particularly out of malted barley, but other things as well. Perhaps in the timescale of things, of all the raw materials, the most recent, of course, is the hops. And although hops were known back in the 1000s, 1100s, and indeed St. Hildegard was credited with stating that beers were wonderful as preservatives for beer. Back in my home country of England, hops were not used until relatively late, the time of Henry VIII and beyond. In those days, they used to call hops a wicked and pernicious weed. So hops is relatively late in the scene, but still several hundred years. So for the longest time, beer has been brewed in a very similar way. What's happened is through science and the advances in science, we've got much better at it. We got much more control over it, much more consistency. And therefore, quite frankly, the beer has never been better than it is now.
I would imagine that there's a lot more variety in beer nowadays than there might have been, 8,000 years ago.
Oh, yes, certainly from 8,000 years ago. And there's varieties and the range of beers available is expanding all the time, and here in North America, there's a tremendous interest in developing newer and newer styles, beers that are developments on what has gone before, but brand new beer styles. I'm thinking at the moment, for example, of things called black IPAs. Back in the UK, where the IPAs originated, there was no such thing as a black IPA. They were IPAs, but now they've combined almost the stout type of beer and the IPA type of very hoppy beer and combine them together. So newer and interesting beer styles are being developed all the time.
So I want to talk a little bit about the ingredients of beer and sort of what's going on under the surface during the malting process. Now, we already talked a little bit about barley, and I believe most beer is actually made with barley. So why barley? Is there a reason?
There is, and the main reason is that barley has a husk around the outside. When you harvest the barley, you retain a husk or a hull. And in traditional brewing systems, that husk forms a filter medium in the brew house. And basically, the liquid, the fermentable sugars in a liquid form called wort that is produced during the extraction of the malt, they are filtered through the spent grains. And those spent grains consist of the husk and primarily, and then you clarify and you run this wort then into the kettle for boiling with hops. So the real reason for barley is historically because it's very convenient to use it in that way. Even beers like Hefeweizens, which are made with significant proportions of wheat, they usually contain a proportion of malted barley in there, simply to provide the husk.
So are there any beer that isn't made with any barley at all?
Yes, there is, and there's a lot of interest in it at the moment, particularly because some people are sensitive to the proteins from barley and wheat, and these, of course, are people with celiac disease. So the proteins, the gluten from the wheat, the hordein from the barley, people with celiac disease can't tolerate them. And therefore, there's a lot of interest in making beers from things that don't contain those proteins. And now, for many, many years in Africa, they have made beer from sorghum. And now in North America, there are several beers that are made from sorghum that are designed for people with celiac disease. Other things as well, people are interested in cereals like, or pseudo cereals like buckwheat. And these sorts of things to make beers that are absolutely free from these sensitive proteins. Having said which, in many of the regular beers, because there's so much protein lost during the malting process and during brewing, there are many beers, mainstream beers, that contain very low levels of the problematic protein in the finished beer. But even then, the recommendation to people with celiac disease is to avoid beer. There are some interesting developments in this area, and there is an enzyme which is now commercially available, which will absolutely get rid of the last traces of these problematic proteins. So it may well be, and certainly is starting to happen, that there will be beers made from traditional raw materials that are categorically suitable for people with celiac disease. But we'll have to see how the legislation unfolds on that.
And do we have a verdict on taste for these alternate beers?
Well, all beer is good beer, and all I would say is, these beers made from sorghum and made from other materials are different. They're perfectly acceptable. They've got very interesting flavors, but they're different. So if you're looking to have a beer which is entirely made out of sorghum or millet or something like that, then it's not going to taste like a classic pilsner or a classic pale ale or something like that. And that, I think, is why there is such interest in finding ways of producing beer from traditional materials like malted barley that is definitely denuded of these problematic materials. And there is real hope of that happening.
So now, malting the barley is, I think, the first step in brewing beer. What's going on at a chemical level there?
Well, barley is very hard, and the reason barley is hard is that it's got all these cells in the endosperm, the storage tissue, and these cells they've got little walls around them, or significant walls around them, and they're packed solid with protein and starch. So it's very, very hard. And there's not much in the way of enzymes that is present in the barley. So when you sprout the barley, you get it wet, you steep it, and then the embryo starts to make hormones, and these follow the water and go into a tissue surrounding the endosperm called the alurone and switch it on, and it starts to make enzymes. And these go into the endosperm and break down the walls and break down the protein and expose the starch. So there's a softening process going on, an increase in the friability, the millability of the grain, so that by the time you've finished germinating, you've lost those cell walls, which contain problematic molecules, polysaccharides, primarily beta-glucans, and you've also broken down or solubilized about half of the protein, but you've left most of the starch behind, which is a good thing because we need to break that starch down in the brew house to form fermentable sugars. So after a period of about 4 or 5 days of germination, then you dry the malt gently to stop the changes taking place. And when you dry it, you ideally, hopefully, and usually do, preserve most of the enzymes because you do it very gently. But the sugars and the amino acids that are produced during the germination phase, they start to react together with the heat through a reaction called a Maillard reaction, and they give you the nice malty flavors and also the color. And the more intensely you heat, the more color you develop and the more flavor you develop. And if you heat very intensely, okay, you lose the enzymes, but you produce those very strong roasted characters and intense color that you get in beers like porters and stouts. So a beer like a porter or a stout is made with primarily a pale malt for the to extract or make the extract and the fermentable material, but quite a significant percentage of these roasted grains to provide that dark color and that dark flavor.
So how do you know when the malt is ready? Are there actually different kinds of malts?
Well, yeah, many different kinds of malts, and I just mentioned one of them, which is these intensely dried ones. So the main malts are the fairly pale malts. For lagers, the classic Pilsner malt, which is very pale, very lightly dried. For pale ales, the pale ale malt is going to be dried slightly more intensely, so it's got more flavor and more color, but still has enzymes. So for any beer, the main malt that is used is there as a source of enzymes and starch. And then to get progressively more intensely flavored and more colored beers, then you add proportions of these specialty malts. So if you take a malt and you stew it and then heat it reasonably intensely, you'll produce things like crystal malt and caramel malt. And these have got nice toffee caramel-like flavors. And a proportion of those in the brewing grist will give you these nice mellow, full flavors, sweeter types of flavors, right the way through to these black and chocolate and black malts that are going to give you more coffee, astringent, dry, mocha, burnt characteristics. The ultimate, of course, and that is what is used in a very famous Irish stout, is roasted barley. They don't even malt the grain; they simply roast the barley, and that gives an intense color, an intense harshness, which when you taste it itself doesn't taste terribly appealing, but when it's part of the stout, deliciously poured with that beautiful white creamy head in Dublin, it's absolutely divine.
So after the malt is ready, what's the next step?
Well, the next step after you've got the malt is you have to store it for a month or so, because if you take the malt straight off the kiln, it doesn't perform well in the brewery, which means it doesn't actually the solid and the liquid, when you've extracted them, do not separate very easily. Having stored it, then you grind it up in a mill, and it's mixed with hot water. The classic temperature is 65 degrees Celsius, centigrade, and at that temperature, the starch in the malt melts, it gelatinizes, and the enzymes, the amylase enzymes from the malt, are then able to break that starch down to produce fermentable sugars. So this is a process that is called mashing, and the liquid that is produced is called wort. And after about an hour or so, the liquid wort is separated from the residual material, as I said earlier, through by filtration through the spent grains. And the wort is run off to a kettle, and that is where it is boiled with hops, traditionally, to extract the bitterness and the aroma from the hops.
You're listening to Skeptically Speaking with guest host Rachelle Saunders, and we'll be right back to continue our conversation with Charlie Bamforth about the art and science of beer in just a minute.
Skeptically Speaking is rebroadcast on a number of fine radio stations. To find out where Skeptically Speaking airs near you, to listen to past episodes, or download the weekly podcast, check out our website at skepticallyspeaking.com. While you're there, follow the links to connect with us on our Facebook page, our Twitter feed, or to subscribe to the show in iTunes. And now, back to the show.
Welcome back to Skeptically Speaking. I'm Rachelle Saunders, guest hosting for Rachelle. Today, we're pouring into the much-appreciated science of beer malting and brewing with expert brewer, scientist, and professor Dr. Charlie Bamforth. Charlie is a professor of Malting and Brewing Sciences at UC Davies and has spent over 3 decades in pursuit of the science behind the perfect pint. So going back to water for a second, I've actually heard that the kind of water used in beer brewing is actually very important. For example, that more calcium is needed to make some kinds of ales?
Yes, there are two extremes in water. The one extreme, tremendously hard water, is the water in Burton-on-Trent, England, and this has got a phenomenal level of calcium in there. And there are various effects that has. One of them is to really lower the pH of the mash. That's because it reacts with things like phosphate and proteins and releases protons and acidifies the mash. And that influences extractability of things. It influences enzymic action and so on. At the other extreme, there is this very, very soft water in Pilsen. And that's got a very, very low level of calcium. So people basically say, well, if you really want to make a great Burton Pale Ale, then you've got to have this very, very high water. Indeed, hard water. Indeed, in Germany, they got that classic German word Burtonization, which refers to adding calcium salts to match the water in Burton-on-Trent. And some people say, to make a great Pilsner, you've got to have really, really soft water. It's not quite so hard and fast as that. But the bottom line is that the water does have a major influence. and you need to control it. The thing about brewing is we try to control everything. We try to achieve consistency. We want to have excellent beer every time. And obviously, if you've got something which is at least 90% of most beers, which water is, that's certainly something you have to control. And if you really are keen to produce identical beer from different breweries, say you're a very large brewing company, and you're brewing in different breweries, and you want to make the same beer in different breweries and have it tasting the same from every one, then you better match the water. And of course, you can do that. You can add salts, you can take salts out. And so although people talk about the terroir of brewing and link it through to the water, and it's, of course, a realistic thing to talk about, nonetheless, I can recreate the terroir of any brewing location anywhere I want in a single brewery. And that's exactly what we do in our experimental brewery here in Davis.
So basically, we can brew excellent German beer right here in North America.
Well, we can, absolutely. And, there's very real reasons why you might want to do that. And the main reason is that beer doesn't travel well, or the vast majority of beers don't travel well. Some of the more alcoholic ones, they will stand up. But certainly most regular strength beers do not like to travel. It's the old adage is, if you want to drink a beer, drink it as close to where it was brewed as possible. So, to my mind, it's far better to brew a certain beer under license, for example, according to the laid down procedures, somewhere that can be many miles away, thousands of miles away from where that beer originates. Because then, as long as it's been done properly, and as long as it's been done using the adjusted water and using the correct malt with the right specification, the correct yeast, blah, 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 and the correct process, then you can produce a perfect match to what that beer is supposed to be. And now it's close to where it's going to be drunk. Therefore, it's not going to go stale. You see, beer develops a pronounced cardboard, wet paper flavor with traveling. And if it's traveled all the way from Europe and it's bounced around on a ship through who knows what temperature, by the time you get it over here, it is not as good as it was when it left home. But if it's brewed over here, then its chances are it is going to be a lot better. And not only that, as I said, most beers are at least 90% water. So it really doesn't make sense to ship water vast distances. It's an expensive business. So that is why there are brewers, for example, famous craft brewers like Sierra Nevada, building new breweries on the east coast of the United States because that was a better way to satisfy that side of the market from the perspective of cost and also from the perspective of quality.
I think actually this might be a related question. We had an audience question from Alan via email. He asks, I've heard that most beer comes in brown bottles because blue light can make beer go bad. Is this true? And if so, how does it work?
Well, if you talk to any technical brewer, they'll say any colored glass as long as it's brown. And any marketing person will say any color as long as it isn't brown, because brown isn't sexy. But, brown is better. For the simple reason that it prevents, for the most part, but not absolutely, but for the most part, the ingress of light that causes beer to go skunky. Now, in particular, we're talking about light in the region of 350 to 500 nanometers. And if it gets into the beer, which it will through a green glass bottle or a clear glass bottle, then it reacts it reacts with riboflavin, and the riboflavin passes on the energy to the bitter acids, the isoalpha acids, and they break down to give the delicious aroma of the skunk. And as you've got a technical audience, it's 3-methyl-2-butene-1-thiol, and it smells of skunks. And frankly, most people don't like the beer to smell of skunks, and that's what will happen if the beer is packaged in that type of glass, unless you actually use chemically modified hops. It's perfectly possible to take hops and extract the resins, and then to produce the bitterness in a factory, and add hydrogen to reduce them. And the bitter acids then can be used to provide the bitterness, but they will no longer break down to give a skunky flavor. So there's a very famous beer in North America that for the longest time has been packaged in clear glass bottles and brewed in the United States that will never go skunky because they have pioneered the use of these transformed hops.
So back onto hops. Now, I know hops is a plant, but I'm actually not certain if the term refers to a certain part of the plant or the whole thing. What part of the plant are we actually using as an ingredient?
Well, what we're talking about is the flowering body from the female of the species. Hops are dioecious. That means there are male hop plants and there are female hop plants. And it's the female that is prized because the female elaborates these hop cones. And in those hop cones, there are glands called lupulin glands, and they contain the resins and they contain the oils. The resins are what provides the bitterness, and it's those resins that are extracted traditionally during the boiling stage in brewing, and they are transformed. They are isomerized, which produces bitter acids that are bitter, but also they help to stabilize the foam. They're also antimicrobial. The downside is they're sensitive to light, as I've just described. The other component of the lupulin glands are the oils, and the oils provide that wonderful hop aroma. If you put the hops in during the start of the boil to maximize the extraction of bitterness, you boil off all that aroma. It's all lost. So what they do in traditional lager brewing is to hold a proportion of the hops back to the end of the boil so that some of the oil remains, and then it passes into the wort. The yeast transforms it a little bit and changes the characteristics of it. And the character in the beer is called late hop character. And it's a very subtle hop character, which is particularly associated with Pilsner styles of beer. For ales, traditionally, what you do to provide a strong hop aroma is to add hops to the finished beer. And this stems back to the traditional use in England on cask conditioned ales of a handful of hops in the finished barrel, so that when you go and have one of those delicious beers pulled in a pub in England, the barrel that the beer is pulled out of has actually got some hops in there, providing this what is called a dry hop character. Of course, over here in North America, and particularly in the craft scene over here in the States, they love their hops, and therefore they don't put a handful in there as a bucket load. But that's okay. And that intense hopper aroma is from the oil component of the hops.
So the next major ingredient in beer, I think, is yeast. And this is where the alcohol part comes in, right?
Well, the yeast, of course, is going to convert the sugars that you've extracted in the brew house and convert those into alcohol and carbon dioxide. The yeast also produces a range of other flavor constituents. For many beers, you may not notice that, insofar as a lot of the character comes from the malt and the hops. But certainly for the gentler flavored lager style products, then the yeast makes a very significant impact. And let me just say that, people are very rude about some of the traditional, should we say, lager products in the United States and Canada, and the traditional North American lagers. Those are very difficult to produce because they're not so intensely flavored that you can tolerate any mistakes. If you make a mistake when you're brewing a gently flavored lager, then you'll notice it. And if you're making one of these more intensely flavored products, you can cover a multitude of sins. So the yeast is making alcohol. It is making some flavor constituents. The worst of these is something called diacetyl, which smells of butterscotch. And in all brewery fermentations, you actually produce that. And few of us want our beer to smell of popcorn or butterscotch. The good news is the yeast will then scavenge it again and get rid of it again. But you have to make sure you leave the fermenting beer and the yeast together long enough for that to happen. And that is a true limiting step in fermentation. So there are many different yeast strains, a lot of ale strains, not so many lager strains. Lager is Saccharomyces pastorianus, ale strains Saccharomyces cerevisiae. But lager strains, you can't isolate them readily from nature. Quite how they arose is a bit of a mystery. There have been some recent studies suggesting that there's an organism that comes from a forest somewhere in Patagonia that it was involved, and that lager strains are really a meld of an ale strain combining with a wine strain called Eubayanus or Byanus many years ago, eons ago. But lager strains are actually more complicated for that reason, but there aren't many of them. There is actually one type of ale strain which is very important and does give a very unique flavor, and that is the ale strain that is used to make Hefeweizen. And that is an ale strain that has got an extra gene in it for making a clove-like flavor called 4-vinyl guaiacol. And so that the presence of a clove and a strong banana-like character, those are characteristics of an authentic Hefeweizen that has been made with that particular type of yeast.
So I've actually lately been branching out into the world of beer and have discovered bottle fermented beer, where some of the yeast is actually left in the bottle. Is there a benefit to doing this rather than filtering it out?
There are various reasons why you would do it, and of course it is a fairly traditional thing. When I was research manager for Bass a long time ago now, we actually, in those far-sighted days, used to have bottle-conditioned beer actually in the laboratory. Can you imagine that? Not even allowed to have water in the laboratory these days, but we had beer, and it would stimulate our brain cells.
Sounds like a great job.
Yeah, absolutely. And this is a beer called White Shield, which had quite a lot of yeast in the bottom. And one of my colleagues, Roy, is a fine guy, good scientist, but 10 o'clock every morning, he would very carefully decant his first White Shield of the day into a glass so as to leave the yeast in the bottle. And then he would drink the yeast straight out of the bottle as his source of B vitamin. So there's a benefit right there. Probably the company in the world that produces more bottle-conditioned beer than any other is Sierra Nevada. And I'm always keen to point out that is the most beautiful brewery in the world, in Chico, here in California. And the reason that Ken Grossman first started carbonating his beer that way and introducing the extra carbon dioxide that you find in beers higher than the level you get out of a fermenter, the reason he did it, he couldn't afford a carbonator. You know, many brewers, they actually, to top up the carbon dioxide into the package, they actually use a carbonator in line. He couldn't afford that, so he actually decided to do bottle conditioning, which is where you leave some sugar in the beer and then add yeast, which will actually produce the carbon dioxide in the bottle. The advantage really is if you've got yeast in the bottle, it does provide some protection. Yeast is a wonderful scavenger of things like oxygen. And indeed, beer in a bottle is less stable than beer in a can because no oxygen can creep into a can, neither can light, but oxygen air can creep in between the neck of a bottle and the crown cork. And so this does happen in a bottle. But if your bottle has got yeast in it, that does provide some protection.
So we've touched on it a little bit, but my understanding is that there are two major sort of divisions in beer brewing. We've got ales and we've got lagers. What's the difference?
It's basically what you say it is. I can remember back in the 70s, a well-known brand of beer, perhaps it was earlier, a well-known brand of beer in England, actually, that was an ale. And then they realized they could tell stories about storage, because that's what the word lager means, to store. And they said, oh, it's a very expensive process, so you have to store it. And therefore, they changed the label and called it a lager. That's a bit naughty. But most people would first of all point to the yeast. So ale yeast, given its druthers, will rise to the top of a fermenter and be harvested by skimming from the top of a fermenter, say an open fermenter, square fermenter. Lagers traditionally are bottom fermenting yeasts, and therefore they sink to the bottom of the fermenter, and usually they're fermented. They are used in fermentation at a significantly lower temperature. But you know, in these very, very big cylindroconical fermenters these days, ale strains they don't rise to the top; they sink to the bottom. Although strictly speaking, a lager is produced with a lager strain and ale with an ale strain, and as I say, the word lager means to store, these boundaries get very blurred these days. The late hopping is associated with lagers, the dry hopping with ales. But there's tremendous blurring of the boundaries between the different styles within the ale and within the lager category, and between the ale and the lager categories. So the purist is mortified when that sort of thing is said. But the reality is that I've been to breweries where they've only got one yeast strain, and they've been putting out beers that have been labeled as ales and lagers. It's a little bit naughty, but that's the real world.
Okay, so maybe you can clarify something when it comes to pouring techniques. Some people insist beer should be poured down the side of the glass to minimize the head, but I've heard others insist if you pour straight down the center of the glass and then wait for the head to settle, you actually get a more draft-like beer with better foam. Can science settle this great debate?
Oh, absolutely. And what you're touching upon now is one of the most beautiful things that humankind has ever seen. We're talking about the foam, the beer. And categorically, you never pour it gently down the side of the glass. That is a dreadful thing to do. You should always pour it with vigor. But the one possible exception is if somebody else is pouring a beer from a tap into your glass on draft, then you do want to make sure you get plenty of beer. But if you're in control of the bottle or the can, what you need to do is this. You first of all need a very clean glass, and you should always wash your glasses before anything else, and never alongside anything else in your sink, never in a machine. And you should always rinse them with clean water before you actually allow them to drain dry. And then you pour them with vigor to the center of the glass. So basically, most of the beer is converted into foam. So what you're doing is releasing carbon dioxide. You're releasing any excess carbon dioxide that might actually give you a little bit too much of a carbonation level. As the liquid drains, the proteins that come from the grain and the bitter acids that come from the hops, they link together in the bubble walls, and they stabilize the foam. And the more foam you produce, the greater is the opportunity for that to happen before the liquid is drained away. And so now you get if you look at it very carefully, you get a fairly solid-looking foam. It's because it's fairly rigid because of these protein bitter acid interactions. And now, as you sip the beer steadily, the foam adheres to the side of the glass and gives you these beautiful cathedral windows of foam adhering to the side of this nice, clean glass. And as I'm usually want to say, never consume with lipstick. And if you've got a mustache, get rid of the mustache. And if you've got a lipstick and mustache, then you're really not going to have a good stable foam on the beer.
I like that we are taking beer very seriously, because I know I take beer very seriously when I drink it.
And, and we've done all this work to actually confirm absolutely and categorically that if a beer has a foam on it, people are influenced by that. And if there's a foam on the beer, they will judge it as being a superior beer. Now, there are some people who claim they don't like foam, but there may be some in the minority, but the majority of people, they are very much influenced by it. I remember at Bass, if we did trials on two beers, and we was trying to see which one tasted better, because there was some difference we expected in the taste. If we actually serve them with different foam performance and different foam stabilities, the one with the better head always was the one that was preferred. People drink with their eyes.
It's amazing how much perception actually changes our taste buds even.
Totally. I remember years ago, we actually took a very famous lager, actually a Canadian lager, which is the best-selling beer in the United Kingdom, called Carling Black Label. And we actually, in an experiment, we actually increased the color and made it look like an ale. And we did it with something that didn't provide any flavor. And when we tasted it without looking at it, there was no difference in flavor. But when we showed it to people and they could see the beer, they scored it, they rated the beers very differently, and they said the beer tasted different. And basically they said the Carling Black Label was a great lager and the other thing was an ale. And it was the same beer. It was the same beer. It just looked different.
So has the information accumulated by scientists like yourself in pursuit of a better pint of beer contributed to other fields of science?
I hope so. I certainly believe so. I mean, and brewing for the longest time has been the home of some great science. And if you look back to Burton, for example, which I would contend is one of the great historic centers of brewing, there was a time when there were three fellows of the Royal Society who were employed in brewing companies in Burton-on-Trent. Um, and they were doing some fairly fundamental work. And they were publishing mainstream work. The first work on enzyme kinetics was done by somebody working on a brewing system, a guy called Adrian Brown. If you go over to Carlsberg in Copenhagen, there's a company which, for the longest time, has dedicated its mission to supporting the science and the arts. And in science, it's out of Carlsberg that the concept of pH arose. It's out of Carlsberg that the famous method for measuring nitrogen arose, the Haldol method. If you go back to Guinness, the student t-test came out of Guinness. There's a man called Gossett who wanted to publish his work on the statistics of barley breeding, and Guinness wouldn't let him, so he published it anyway under a pseudonym, student. And so the list goes on. So, if you look back, so much of the things that are applied these days came out of the brewing industry. Look at the modern day biotechnology industry. All of that fermenter design, the cleaning of fermenters and so on, and the use of pure cell cultures, that came out of the brewing industry. A man called Emil Christian Hansen in Carlsberg back in the last decade of the 19th century was the first guy to basically isolate pure cultures of yeast. And this is the norm worldwide now to use pure cultures of a single strain. And of course, that technology is now applied in wherever pure cultures of organisms of whatever type are applied in industry. So yeah, and this continues to happen. That brewing has got a long and a very proud history of publishing, and through organizations like the Institute of Brewing, the American Society of Brewing Chemists, a lot of papers are published that are widely cited elsewhere, and the stuff we do on barley and yeast and so on is picked up by people in lots of other walks of life.
So, talking a little bit about the wholesomeness of beer, which is something I actually grabbed from your website. Tell me when I can expect science to tell me that beer is healthy for me.
Well, it is already. It's already telling you that. But of course, people are got a false perception. Beer is perceived as somehow being unhealthy, and people, of course, the first thing they say is, "Oh, the beer belly." Well, there is no such thing as a beer belly. It's all about calories in and calories out. And of course, the main source of calories in any beer is alcohol, just like it is in wine or any other alcoholic beverage. And if you count those calories, and of course, yes, there are some coming from some carbohydrates and from the protein and so on, but the main amount is coming from the alcohol. But if you count those calories in beer and you include it among your calorie count, and as long as you burn off more calories than you take in, you ain't going to get a beer belly. It is as simple as that. It's a complete myth. The fact is that people who drink beer, many people who drink beer, perhaps don't do that. They don't count those calories. What I'm fond of saying is, people who drink wine jog and belong to health clubs, but people who drink beer eat burgers and watch ball games. It's a lifestyle thing. But there's absolutely no reason why beer cannot be part of a very healthy lifestyle and a very healthy diet. The wine guys, they really did steal the moral high ground with all this business of the French paradox and drinking wine, cutting down the risk of atherosclerosis, and linking it through to something called resveratrol, which is a complex polyphenolic from the skin of the grape. Well, in passing, I would say that there is resveratrol in hops, but that's not really important either, because the active ingredient in any alcoholic beverage that cuts down the risk of atherosclerosis and bad cholesterol is actually alcohol, and beer is just as effective as wine. And the reality is also that beer actually contains more nutritional benefit. Beer is the richest source of the element silicon in the diet, and that has been linked by some medics in the UK into reduced risk of osteoporosis. Beer contains significant levels of several B vitamins. Beer contains some significant levels of soluble fiber and possibly some prebiotics. Beer contains antioxidants, and in fact, it has been shown that at least one of the antioxidants from beer, ferulic acid, does actually get into the body. And that is what it's all about. So many of these claims on antioxidants for foodstuffs say, oh, there's loads of the antioxidant. But if it doesn't get into the body, what's the point? We know that ferulic acid from beer does get into the body and hopefully does some benefit there. So the simple reality is that beer has been linked to a wholesome lifestyle. For the longest time, people have suggested that beer may promote lactation. Beer cuts down the risk of kidney stones, cuts down the risk of gallstones, improves cognitive function in the elderly, and the list goes on.
So, since you're on the cutting edge of beer research, can you tell us what your current research topics include?
Well, that is the whole health thing is one of them, and of course the difficulty is that if you are a professor of brewing science, there's a lot of people out there who say, well, we can't trust you because you're going to say that, aren't you? Which I rather resent, because what we try to do is to be as even-handed as possible, and certainly to point out the downside. And just as much as there is an upside. If you abuse anything, in that it would include alcohol, it ain't going to do any good. For the longest time, we've done work on foam, so we're quite well known for that. We do a lot of work on freshness and how to preserve the freshness of beer. Recently, we've done work on hop aroma and how to celebrate the hop rather more. The wine guys, and some of my really good friends are in the wine business, but of course they make there's no bones about actually celebrating different grape varietals. Well, we can do that with hops as well. And there's so many different hop varieties which have got all sorts of interesting flavors associated with them. And depending on how you use them in the brewing process, you can introduce all sorts of flavor characteristics, aroma characteristics into beer. So we're very keen on that area as well. We continue to find new enzymes that nobody's ever worked on before in malt particularly, and the list goes on. I've got a fairly extensive research interest, and basically, if a student has got some interesting project that they would like to work on, then the chances are I'll let them do that.
And we're unfortunately all out of time. Charlie, thanks for joining us today.
My absolute pleasure. Thank you.
If you want to learn more about Charlie Bamforth, the science of brewing, and see his collection of books on the topic, you can visit skepticallyspeaking.com, where a link to his website will be available in our show notes.
On the next episode of Skeptically Speaking, we're taking a look at the questionable practices and suspect science employed by the companies that make our most widely used prescription drugs. We'll speak to Dr. Ben Goldacre about his book, Bad Pharma, How Drug Companies Mislead Doctors and Harm Patients. And we're joined by Dr. Stephen Novella to talk about the practical pitfalls of using animals to test drugs and procedures meant for humans. That's next week on Skeptically Speaking, on your local radio station, or online at skepticallyspeaking.com.
This is Skeptically Speaking, and I'm Desiree Schell. I'm talking to Dr. Rob Tarzwell, a clinical assistant professor on the Faculty of Medicine at the University of British Columbia. He has a dual specialty in nuclear medicine and psychiatry, and he is also the creator of the 1 Minute Medical School videos on YouTube. Hello again, sir.
Thanks for having me back.
Hangovers. So you were actually on the show a few years ago to go over this topic, and you basically crushed us all by telling us that there is nothing that truly cures a hangover. Is that a reasonable paraphrase of that show?
That is essentially correct, yes. The hangover is a complex phenomenon that essentially involves three things. One is dehydration. The other one is metabolic derangements of certain ion levels, especially sodium. There's glucose depletion. And then fourth, and the most difficult aspect of the hangover, is really the slow clearance by your liver of the toxic intermediate products of alcohol, essentially acetaldehyde, which is the thing that makes you feel yucky and sick and terrible.
How about the psychological effects the next day? There's a bit of a blues.
Yeah, that's probably a link with the toxic effects from acetaldehyde. Typically, in any toxic state or metabolic derangement, you will have a degree of body-wide or systemic inflammation. And this is a sort of a generalized immune response. It's sort of like letting the bloodhounds loose and they're kind of sniffing around. Okay, what's going on? What's going on? What's going on? Where's the thief? Where's the thief? Where's the thief? And we know that those chemicals involved in inflammation, specifically cytokines, are actually able to cause you to feel sort of weak and fatigued and achy, and can actually acutely depress your mood.
Well, so as you said, nothing you can do about it, but that was 3 years ago. So sometimes you give science a few years, give it a bit of time, and it does amazing things. So certainly there have been some developments in this area, correct?
Well, research is ongoing, of course. This topic of, I think, perhaps even urgent interest to all. So you can understand why there might be ongoing research into this. I mean, I think if you could create the hangover cure pill, you would die wealthy beyond avarice.
And also with the love of many, many citizens.
Yes.
Love.
Yes.
So I recently saw an article about some research around hangovers and asparagus. Now, that was new to me. The article said that the asparagus was shown to metabolize alcohol, which is wonderful, correct?
Well, it's, correct me if I'm wrong, but was that an in vitro study? In other words, looking at alcohol in a dish with asparagus enzymes?
I see where you're going with this, sir.
Yeah, yeah. Here's what happens when you eat asparagus. All those lovely enzymes, your body doesn't know that they're enzymes. It just sees protein. And the protein destroying machine goes to work and breaks them down into amino acids. And then you absorb them and you make them into your own proteins. The main exception to this general rule would be people who have pancreatic insufficiency and therefore actually can't make enough pancreatic enzymes of their own to break down proteins, and those individuals take pancreatic enzymes so that they can digest meals. But all other enzymes, unfortunately, meet this final common fate.
So, does it stop hangovers?
Oh. But it's pretty tasty.
All right. So So that research that they did then, what did that show?
I'm not specifically familiar with the details of that research. So again, I'm open to being corrected on this. If it's an in vitro study, typically what they might do would be to measure actual rates of alcohol metabolic product breakdown, so acetaldehyde breakdown through exposure to different chemicals in various mixes. The way to do it in human beings would be, it would actually be really funny research to watch on a documentary. You'd have to get people really hungover and then feed them asparagus and see what happens.
Are there ethical considerations there?
Well, there might be, but I suspect you'd have no problem finding volunteers who are fully familiar with what a hangover is and therefore can truly give informed consent to participate in the study.
College campuses. This is the key to all research. So, okay, how about eggs? Supposedly they contain large amounts of, I might be mangling this, cysteine?
Cysteine, yeah.
Lovely.
Cysteine is just an amino acid. It's one of the 20 amino acids that are in all proteins. And, I mean, sure, cysteine is important in the building of the body's own enzymes to break down alcohol. That's specifically alcohol dehydrogenase. But you don't get any magic boost just from having lots of cysteine around. In fact, your body can make cysteine if you haven't got enough of it. Your body's quite good at interconverting amino acids to other kinds. And so, yes, I saw that popular report of eggs, and it unfortunately lacks any evidence-based merit.
I have to point out that there was a How Stuff Works article that actually came to the conclusion that eggs could help. That it was part of a hangover article that pronounced eggs as a hangover remedy as fact.
Yes, I read that article, and I noticed
Yes.
the extraordinarily high concentration of waffle language in all the conclusions. But hey, by all means, go ahead and try eggs. Go for it.
Well, I'm just full disclosure here. I didn't actually research this before. I just thought it might help and maybe placebo effect. So I have actually had Sunday mornings asparagus omelets.
Oh, yeah?
Because those two, you know, maybe a magic bullet.
Well, I mean, I would say that if you eat an asparagus omelet and you feel better, well, you just feel better.
But you're saying there's no reason for that. You are the biggest buzzkill, sir.
I know.
That's what we do.
But the placebo effect doesn't mean nothing is happening. It means something is happening, but whatever is happening cannot be attributed to any active effect of the supposedly active agent.
So I'm going to continue to eat asparagus omelets and pretend we never had this conversation.
They sound perfectly lovely. And in fact, there is a significant percentage of placebo responders who continue to respond to placebos, even if you tell them as part of an experimental setup, this is a placebo. It contains no active ingredient.
You're saving this interview, sir. So once more for the cheap seats, though, are there any effective hangover remedies?
Moderation. I wish it were true. I believe me, I would love to know that such a beast exists.
You guys, I'm trying. I'm trying as hard as I can.
I will continue scouring the scientific literature.
Rob, great to have you here.
Great to be back.
And we will definitely see you again soon.
Okay.
You can find a link to Dr. Rob Tarzwell's 1 Minute Medical School on our website at skepticallyspeaking.com. Since you're there, why not click the links to Facebook, Google+, and Twitter? You can also visit iTunes, where you can subscribe to the show, listen to past episodes, or leave a review. Thanks for listening, and we'll see you next week on Skeptically Speaking. Hello, listeners. I'm Desiree Schell, host of Skeptically Speaking, here to let you know about a change that we're making to the way that we produce the show. After 200 episodes and a lot of thought and deliberation, we've decided to stop recording interviews live on Ustream. The added flexibility in our schedule will give us more options for booking guests and allow us to keep bringing you an hour of in-depth, science-minded discussion every week. We definitely still want to give you the chance to submit questions for our guests. So we're going to start posting about upcoming interviews on our website and sharing links on our social media feeds. And for more on that, do look us up online at skepticallyspeaking.com. From myself and from everyone here at Skeptically Speaking, we hope that you'll join us for another 200. Thanks for listening.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, break the spell of Pavlov's spells. Cause we're skeptically speaking, our mind reading tarot cards and witches, psychics, and their spoon-bending mind tricks. All the humbug, flim-flam, frauds and shams, the charlatan woo. I don't think you understand, it's the hocus pocus, out of focus locus, eroding the brain, making gains on the hopeless. Let the crystal ball fall, smash on the floor, leave the pieces alone, we don't need them anymore. Just a microscope, telescope, magnifier, reading in between the lines of these lies. Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, metaphorically that is, cause we're skeptically speaking.
Skeptically Speaking is produced and distributed by Suburban Panic Media. Our guest editor is Rachelle Saunders. Our production assistants are Helen Quavillion and Chelsea Butler. Ryan Bromsgrove is our production manager and assistant editor. The show was edited by K.O. Myers. Our theme song was written and recorded by A.OK. And I'm your host, Desiree Schell.